Okay, this is number 35 on lesson 6.2. It's a definite integral again because you have a definite starting and stopping boundary. We're going to use U substitution because it looks pretty complicated. U substitution is a method to help make the problem look simpler so that we can do the integral. Then we can go back and plug in the theta expression if we need to. I see 1 plus theta to the 3/2 in the parentheses, so I'm going to let that equal U. So the derivative of that is going to be 0 plus 3/2 theta to the, what would the new power be? Take 1, 3/2 minus 1 would be a half, right? Okay, let's rewrite this a little bit. So it looks, and we could also write it like this: 3/2 times the square root of theta. Right? Theta to the half is the same as square root of theta. There's my du. That's what I need to get right here. So the one thing I could do is move this square root of theta over here. Let's get this 10 out of here. Let's move that over to the left because I don't see a 10 in the problem anymore. I don't really need that 10 in the actual integral. So I'm going to rewrite this as 10 times the integral of, the denominator I'll have, what will I substitute in for 1 plus theta to the 3/2? U. So I'm going to have U squared. Actually, let me not, I don't want to skip that step. Let me just rewrite this first. So I move the square root of theta off to the right. If there's nothing left in the fraction, you want to put a 1 above it. Now we'll make our substitution. For 1 plus theta to the 3/2, we're going to put a u. So you're going to have 1 over u squared. What do I substitute in for this again? Du. Yep, that's my. Oh wait, but I need a number in there, don't I? What number do I need in there? And I forgot my d theta on my derivative here. I need a 3/2 in here, don't I? Yeah. So in this case, you're going to have to put a 3/2 in there. So if you put a 3/2 there, what are you going to have to put out front? 2/3. All right, multiplied by the reciprocal. So that's going to actually turn this into 2/3 times 10. That's going to be 20/3 out front. And our 3/2 square root of theta d theta, I can change that now to du. Wow, this looks a lot simpler than what I had when I started, doesn't it? And that's the idea. Make your expression simpler. Any questions? Let's keep going here. Let's rewrite this as 20/3 times the integral of u to the negative 2. So I'm going to move this u squared to the top and call that u to the negative 2. Now, what am I going to do the integral of u to the negative 2? 1 bigger, so that would be u to the negative 1. Then take 20/3 divided by negative 1 would be negative 20/3. Now, if this was an indefinite integral, if there were no bounds on it, I'd put a plus c on it. But since it's a definite integral, we're going to put a square bracket here. And let me bring this up where we can see it better up here. Let's rewrite that as negative 20/3. And let's put that, where would I want to put that u if I want it to not have a negative exponent on it? On the bottom. So let's put it down here. And our boundaries were 0 and 1. But once we switch from theta to u, we need to switch our boundaries also. So when theta equaled 1, u would equal, let's use this formula right here. If theta was 1, so you'd have 1 to the 3/2, which would be 1, plus 1 would be 2. So when theta is 1, the u value is 2. So instead of a 1 for the upper bound, we're going to use a 2 for the upper bound. This would have been a 2 all the way through here. Why do we do that? Is that your question? Yeah. Well, because we're switching variables. We're switching from thetas to u's, and normally when we plug in the numbers, like we would plug 1 in for theta, when we plug 0 in for theta. Well, so these values are normally getting plugged in for theta. If we're going to plug them in for u, we've got to figure out what these would represent as a u value. And we know that u is equal to 1 plus theta to the 3/2. So let's also do when theta equals 0, let's figure out what u would equal. Well, 0 to the 3/2 would be 0. plus 1 would be 1. So when theta is 0, my u value would be 1. So you just have to convert your bounds, which, normally, let me try to draw you a picture here. Normally, if we were going to do an integral, we'd be finding the area under a curve, right? And our bounds would be 0 and 1. And this integral would give us this area in here, okay? But if we're going to switch to a new equation, or new expression with u's, that's going to change the curve, and it's also going to change the bounds. So now we're not going to go from 0 to 1. Instead, now we're going to go from 1 to 2. Then you plug in 2, so it would be negative 20 over 3 times 2 minus negative 20 over 3 times negative 1. That's going to be negative 20 over 6 plus a positive 20 over negative 3. Let's keep going here. Let's reduce. Divide these both by 2. That'd be negative 10 thirds plus 20 thirds. Or no, that'd be negative 20 thirds, wouldn't it?
Why negative?
No.
I mess up?
It should be positive 20 thirds.
Positive 20. What did I do wrong? Oh,
No, you plugged in a negative 1, where you should have plugged in a 1.
Yeah.
That was it.
where did I do that at?
At the negative 23 times 2, no, over. Cross by your arrow, yep, down a step, right there. It should be a 1.
Oh, yeah, why did I plug in negative 1?
I was like, what?
I'm just seeing if you guys are paying attention. Yeah, and a lot of you were. If you didn't notice that, that means you're probably daydreaming. Okay? Okay, there we go. So, negative 10 thirds plus 20 thirds, what's that equal? 10 thirds. Negative 10 plus 20 is 10, so 10 thirds would be your final answer there. That's a doozy. Any questions about that one?